So now let's take a moment to talk about databases. Right? So when we are coding our applications are going to need to be able to read and write data from somewhere. And so we talked about file stores. And so what file stores are is where you're going to be storing actual files. This may be pictures, this may be video files, audio files, even your CSS style sheets are files. So that the files are going to be in the file store. So you may have a volume directly on your computer. So if you create a web application, you're delivering it with Apache or Nginx, you may simply have a folder on your machine and that's your file store. Or you may be using a storage bucket at AWS or Azure, something like that, and that is where your files are stored. And so that is one type of data. The other type of data that you're going to be interacting with your application is going to be records. And so what records are is they're simply records, basically values. So imagine a person's information, right? Last name, first name, date of birth, email address, and t-shirt size, something like that. That is a record. Something in an inventory system, right? The part number, the part name, the price of the part, the description of the part, and the vendor of the part. That would be a record. And that's what we're talking about when we're talking about databases. So when we're talking about databases, more or less, there's two overall types of database systems. There is a relational database system that works under the concept of ACID, and there is a NoSQL database system that works under the concept of base. Now, we're not going to get a lot into this in this particular class, and we're going to have much more in-depth classes about all of this later. I just want to give you an idea of what we're talking about here with relational and NoSQL databases. Basically, with a relational database, the important thing to understand about this type of database is that you define exactly what data the database is supposed to collect, and then the database reliably collects and stores that data. As soon as a transaction goes through, the value of that transaction is accessible by anybody that is interacting with the database system. So there's something called a schema. And so what the schema is how you design the collection of the data that's going to be going into the database. And the idea is under that schema, so you have a last name column, you have a first name column, you have a email address column, and that's where that information goes into. You actually program in and you say, in the last name column will be this, and the first name column will be this, and the email column will be this, so on and so forth. So that's the first thing, is that it has the schema there. You actually design the data that the database will take. The other thing is that once the transaction goes through, that it will be immediately accessible by anybody else connecting to that database server. So imagine you have an invoicing system or a payment system, essentially any type of system where as soon as somebody does something like make a payment, right? As soon as the person makes the payment, that payment should show up in their balance. You don't want that payment to show up in their balance tomorrow or even an hour from now or something like that. As soon as the transaction is recorded, it is now available for everybody to see. So it's one of those things with payment systems and that type of deal that's very important. And that's the overall concept of a relational database. Now, the thing is, with the relational databases, there's a lot of planning that's required to create these relational databases. And the relational databases require a significant amount of hardware resources because basically, again, every time that transaction goes through, it has to be available, so you actually have to process things very quickly. The issue then is to build out the database takes time and energy and planning, which nobody likes to do. Right? And then the other issue is as you try to scale up the database, since there are so many parameters that have to be set, that you run into a problem where it can be very difficult to basically scale the database beyond what the original concept was. So let's say you created a database. Again, think about this. Let's say you created the next Facebook, but you weren't planning to create the next Facebook. So you create your little database, you have your little app, connected to the database, and you have some people sharing messages. Well, what happens when 20 people share messages a day? And then 200 people share messages a day, and then 2,000, and then 200,000. Right? Again, a database system is a system like anything else. The more activity that's going into that system, the more resources that are going to be used. And so at a certain point, you're going to have to scale up. With relational database systems, the issue is scaling the systems can be very time-consuming, expensive, and difficult. So there's something called a NoSQL database system. And basically, with a NoSQL database system, it works under something called the base principle. But the big deal here is that you don't have what's called the schema, right? So the schema is the design of what the database is supposed to look like. And basically with a NoSQL system, you don't have to worry about the design. Literally within the code, when you write the code in Python or JavaScript or whatever else, when you write the code, you say essentially what the keys and the values are as the code is putting it into the database. So you can do first name, last name, whatever. If you want to add a value, you just add a value. If you don't want to put a value in, you just don't put a value in. So you're not restricted to whatever the initial schema was when you created the database system. So that can be very useful. Beyond that, with a NoSQL database system, what's really nice, it is incredibly easy to scale. Basically, depending on what system you use, you can spin up some servers, essentially connect them relatively easily, and they just scale, right? NoSQL database servers are incredibly fast. They don't use as many hardware resources, and it's very easy to scale. The issue, though, of why it's not so easy to scale is under the base concept of databases, is that there's this idea of eventual consistency. And one of the concepts is that if you lose a transaction, oops, right? So think about this. If you're creating a banking system, right? You're creating a banking system. The most important thing to you is that you don't lose a transaction, right? If somebody gives you a payment and then that disappears, that is a really bad thing. So you're willing to create a schema and go through the whole relational database deal just so you don't lose transactions. But here's the deal. What if you're coming up with a new social media site? You're coming up with the next version of Twitter. So you want people just to be able to hammer the hell out of your system. And honestly, if you lose a tweet every once in a while, who the hell cares? Like literally, who the hell cares, right? And so that's one of the things with a NoSQL is it's very easy to modify things and scale things, but every once in a while, you might lose a transaction. Oops. And then the other thing is the idea with eventual consistency is, especially if you have multiple database servers, the idea is that when you complete a transaction, that will get replicated out to all of the other database servers at some point, eventually. Right? So if I put a post, right, I add a post to my new Twitter account, right? And then somebody comes to my feed to look at, what I've posted recently. If it takes a minute for my new post to show up there, or even an hour, or even a couple of hours, it's not the end of the world. It's not generally that long. Again, eventual consistency is normally seconds or minutes, maybe. It's not generally going to be hours. But the idea here is with the eventual consistency, I added a transaction into the system, and then eventually everybody will be notified of the transaction. And so that's a big thing with the NoSQL that, again, depending on the type of application you're creating, may or may not be useful for you. We won't go any farther here with talking about databases, because databases is a big deal. So being a database administrator is literally a career field on its own. Just like there's front-end developers and back-end developers, Python coders and Node.js coders, basically you can be a database administrator and you can literally just deal with databases, for for your job. There's a lot more that goes to it. We already have classes here at Silicon Dojo for SQL. It's called Structured Query Language. This is for relational databases. So if you're interested in databases, you probably want to take that class, and we will have more database classes as we go. In order to understand the concepts of relational databases and NoSQL databases more, it's better to actually, get into the nuts and bolts of it and actually start working with it. But I just wanted to give you the basic concept here of what relational databases and NoSQL databases, what they're doing.